Let's say you've got a box or a drawer somewhere around the house that has batteries in it, right? Tons of batteries, all different kinds, and from who knows when. And you're really not sure if they're charged or not, and you're really not sure exactly how to figure it out. Well, that's where the multimeter comes in handy. And a multimeter looks like this, and this is an auto range finding multimeter. They come in a lot of different shapes and sizes. This is another example of a multimeter, and this one's a manually calibrated multimeter. And what you could do with a multimeter is, well, you could do a lot of different things with them, but one easy thing to do is to check the voltage on batteries. Since all batteries are DC in nature, all you have to do is select voltage DC on the multimeter in order to be able to quickly test the state of the battery. So here I've got volts DC selected. Now all I have to do is to use my two probes here, my positive and negative, the red being positive, black being negative, to check the status of any of these batteries. If you're using a manual multimeter, then you're going to go ahead and select 20 on the volts DC side of the multimeter. And the volts DC side is indicated by a solid line with a dashed line underneath of it. And that's in opposition to the volts AC, which has which is on the right hand side here, which is with that little squiggly line, that waveform. On my orange one here, we just have volts DC and volts AC actually labeled, not using the images. So here I have a power tool battery, right? This is a 19-volt battery. And in order to check the state of this battery, all I really have to do to connect the positive and negative probes to the terminals of the battery. Now, this particular battery has 4 different terminals inside of it. And really all you have to do is just pick any 2, and you should be able to get a voltage. And if it's not the right 2, just try 2 others. And just keep going until you can find a voltage. In this case, it was registering 20 volts, and so we know that this one is fully charged. If we were to take this AA, for instance, or this D battery, which are supposed to be 1.5 volts, all you have to do is connect the positive to the positive and the negative to the negative, and you're going to land up with a voltage read. And in this case, it says 1.5 volts. It's worth noting that if you accidentally use the opposite leads, or the opposite probes, so the negative to the positive side of the battery and the positive to the negative side of the battery, the multimeter is going to give you a negative reading. So it says 1.5 volts, but it has a negative sign in front of it. And that's perfectly okay. It's really all that it's telling you is that it does register a voltage, but that your leads or your probes are in the opposite orientation. So there are times when you might run into a battery that you can't identify which way is positive and which way is negative. And this will be another helpful tool to help you figure out, what the orientation is. Now, a lot of batteries that you have are alkaline, and a multimeter works perfectly fine for those. Likewise, it'll also work for nickel metal hydride. It'll work for cadmium. It'll work for lithium, lithium polymer. It'll work for pretty much any type of battery that you have. So regardless of the battery's chemistry, you can still use the multimeter to figure out what the charge is. Now, if you have a big battery, such as this tractor battery, the process is exactly the same. It is worth noting that you should be careful when you're doing larger sized batteries, and really all batteries for that matter. With anything that carries a significant amount of potential amperage, which is something like this battery, you just want to be careful about what you're doing. In this case, all we're doing is touching our leads, our probes to these terminals, and I can see, actually let me pull this up here. I'm just pulling this up here, and I'm just testing it, and I can see that this has a voltage of 12.61 volts. And really, the only thing, when I say be careful, you just don't want to touch both sides of the battery with your hands or with wet hands. You just don't want to create any situation where that power, that electricity, could be coming through your body. Finally, if you are trying to get the voltage read off of a pack, and in a pack, the batteries can be oriented in a lot of different configurations. There might be 3, and they might be in series with each other, so 1.5 plus 1.5 plus 1.5, or they might be in parallel to each other, so you might have 1.5 volts, but at a much longer runtime than a single battery. What you can do to figure out what the orientation is, and what the voltage is, if, say, your ends, your connectors, are just not quite large enough to be able to easily test, what you could do is you can actually, let me move this out of the way here. You can actually test by getting that probe, one probe down into one corner and another probe into the opposite corner, and check to see what the voltage read is. In this case, I'm seeing negative 4.2 volts. So I know that I have 4 volts coming out of this, or what should be 4.5 volts, but these are rechargeable, so they're a little less. And I know that my leads my probes are in the opposite orientation. So I now know what the voltage is coming out of this. I know that these are running in series. So that's what I was looking to find out. So there you have it. Using a multimeter to check your battery voltage and to see which ones are good and which ones are bad is a fairly simple and easy process. I hope that this helped. If you want to, go ahead and leave a comment down below. Please click the like button, subscribe to get notified of when we have new content coming out, and of course check out our other channels as well. Until next time.